All right. A little soon. Here we go. All right, let's do number 18. Yeah, for sure. Okay, so let's start with number 18. Here we go. Number 18. With number 18. When we start with number 18, when you do a problem like number 18, and we're starting with 18. So the first thing I want to do is subtract 5. I want to isolate my x term with that weird rational exponent, or fractional exponent, equals negative 81. You have to divide by negative 3 first. So I get x to the 4 thirds equals 27. Okay. I have my fractional exponent. Remember, just like on the last problem, like on number 17, okay, to get rid of a fractional exponent, I raise it to the power. I raise it to the reciprocal, to the 3 over 4. 27 to the 3 over 4. And remember, if you're doing this in your calculator, okay, you should use parentheses. Use parentheses around that 3 over 4. All right. You should get x equals... why did I say, okay, hold on. Alright, so the review packet actually has, this is 3 over 4. I don't know why my review packet had 4 over 3. So this was 3 over 4. So this was 3 over 4. So this I would raise to the 4 over 3 power, to the 4 thirds power. Sorry about that. I don't know why this came up as 3 over or 4 over 3. Either way, whatever. I get 81. Okay. The most important part is if I have a fractional exponent, I raise it to the reciprocal. Okay. Okay. All right. So now here's the deal. I could do this 2 ways. I can use U substitution, or I can just factor straight up. All right. I'm going to use U substitution just because I like it. And I'm going to say 6u squared minus 5u minus 21 equals 0. Now, I could do 6 times 21 and then find out 5 and blah, for sure. However, should we do that? Let's do it. How about this? All right, so 6 times 21. I haven't done this yet, so I'm going to... Now, you could choose to do the quadratic formula. When I did this originally, I did do the quadratic formula. However, I'll show it this way, just so we can practice splitting the middle term. So I want 2 numbers that multiply to negative 126, doing 6 times negative 21, and add to negative 5. I found that negative 14 and positive 9 will give me there. So again, factor by grouping. Here I can take out a 2u to get 3u minus 7. And here I could take out a 3u to get 3u minus 7 again, equals 0. Alright, so I have 2u plus 3 equals 0. So u... Oh, buckets, I just skipped a step, didn't I? I don't want to skip around, Fanya. That's on me. Oh, buckets, now it just... Okay. 2u plus 3. And we're back. So that 2u plus 3. And I get 3u minus 7. And it equals 0. So u here equals negative 3 over 2. And 3u minus 7 equals 0. So u equals 7 over 3. Alright, so since I use u substitution, I'll have x squared equals negative 3 over 2. And x squared equals 7 over 3. Square root both sides. X equals plus or minus. Now I'll have, I'm going to have an I. I have I root 3 over root 2. Remember, you can't have a radical on the bottom, so I must rationalize my denominator. So I'll have times root 2 times root 2. So my answer will be plus or minus I root 6 over 2. All right. Same thing over here. Square root top, square root bottom. X equals plus or minus, that's a 6. Root 7 over root 3. Rationalize, multiply top and the bottom by root 3. X equals plus or minus root 21 over 3. There you go. Fun. Okay, now we are going to limits. Limits graphically. So remember limits. Remember we have our right-hand limits and our left-hand limits. If we want to evaluate the limit of a number, then both of them must be the same. So if I want to find the limit as x goes to 1, the right-hand limit and the left-hand limit must be the same in order for it to exist. Well, if I approach 1 from the left, I get 1. And if I approach 1 from the right, I get negative 1. So since 1 and negative 1 aren't the same, this limit does not exist. Okay. If we look at 4, if I approach 4 from the left, it goes off to infinity. If I approach 4 from the right, it goes to infinity as well. Now I can say infinity, or I can say does not exist. Either one acceptable. Negative 2. Negative 2 from the left is 3. Negative 2 from the right is 3. So the limit is 3. 3. 3 from the left is 0. 3 from the right is 0. So I get 0. Infinity. What? Infinity, as x goes to infinity, y is approaching. It's getting closer and closer. It's looking like it's leveling out, okay, at 0. All right. Make sure like that's leveling out. It's not necessarily going to cross that x-axis, although it could, but we're going to assume it's not going to cross that x-axis here. Okay. So I'll write 0. F of 1. Find the value of our function at 1. What does y equal at 1? Well, if I look here, that's an open circle. So I disregard that and go to the closed circle. I get negative 1. F of 4. Well, I have this vertical asymptote. If I have a vertical asymptote, it's D and E. Okay. Algebraically, first thing I want to do is direct substitution, so plug it in. Direct substitution. 3 squared is 9. 9 times 3 is 27 minus 24 plus 1. That's 3 plus 1 to get 4. Okay. Direct substitution. If I plug in 5, I get 25 minus 25, which is 0. I get 5 minus 5, which is 0, which tells me I have to keep going. Okay. Our numerator can be factored as x plus 5, x minus 5. And I have 5 minus x, but I want x minus 5. So I can take that negative 1 out to switch the sign of each of my terms so that my x minus 5s can cancel. Okay. Now technically that negative 1 is in the denominator, but remember if I have x plus 5 all over negative 1, that's the same as this. Negative 1 times x plus 5. Okay. Then just plug it in. Plug in my x. I got 5 plus 5, which is 10, times negative 1 gives me negative 10. Another limit algebraically. If I plug 0 in, all right, 0 minus 0 minus 0 over 0, I get 0 over 0, which means I got a kg. Keep going. All right, I could take out a GCF in my numerator, x times x squared minus x minus 6 all over x. X's cancel. So plug in 0 into x squared minus x minus 6, and I get negative 6. Because this becomes 0 and this becomes 0, you get negative 6. Okay, plug in 36. 36 squared 36 is 6. 6 minus 6 is 0 over 0 kg. Okay, if I have a kg, that means I got to keep going. Well, I have an issue here. I can't factor, right? This doesn't factor, so I have to multiply it by the conjugate. But what's causing the issue? The square root. So I have to multiply my numerator and denominator by the square root of x plus 6. The square root of x plus 6. Okay, so if I multiply the top, I get x plus, I'm going to pause for a second. Alright, so what's going to happen? 6 plus x, 6 minus, or negative 6, these are going to cancel, right? So I'll have x minus 36 in my numerator, and I'll have an x minus 36 in my denominator as well. Remember, don't actually multiply these out, just leave them as is, because more times than not, something will cancel. Okay? Something will cancel out. And then I want to take the limit as x goes to 36. And remember, when I cancel, that means there's still a 1 left over in my numerator, and then my denominator is just whatever's left over, root x plus 6. God bless America. So if I plug in 36 here, well, the square root of 36 is 6. So it's 6 plus 6, which is 1. 12. We're still going. Evaluate limits as x approaches infinity. Okay. Well, as x approaches infinity, we have buckets. We're looking at bottom heavy, top heavy, even heavy. Remember, if it's even heavy, it's leading coefficient over leading coefficient. If it's top heavy, it's a slant, and I have to divide. And if it's bottom heavy, it's just 0. So here we have a bottom heavy. Okay, the degree on the bottom is greater than the degree on the top, so my answer is 0. Here, even heavy, I have 8 over 3. Take my leading coefficients. All right. This next one, I'm going to have to pause and graph it real quick. So if you look at this graph of y equals x squared plus 4x, as x goes to negative infinity, what's y doing? Y is increasing forever and going to positive infinity. So here for 26, you could write infinity or does not exist. When you think about this, okay, don't think about substituting negative infinity in. Look at the graph. All right, look at the graph. Yeah. I'm going to pause it, and then we're going to come back and start off on 28.